Everyone, welcome back. Let's write some more Leetcode today. Today we are solving product of array except self. So the problem states that we are given an integer array nums and we want to return an array answer such that the answer of I is equal to the product of all the elements of nums except nums of I. And the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So let's look at this example. For 1, we will multiply everything except for 1. So 2 times 3 times 4 equals 24. And at this index, 1 times 3 times 4 equals 12. At this index, 1 times 2 times 4 equals 8. And at the last index, 1 times 2 times 3 equals 6. And we cannot use any division operation, or else that will make the problem much easier since we can just loop through and multiply by everything and then divide by itself. Now, some people might think that we can just go through every index and multiply by everything by itself, and that should give us the solution. But that would take O of n squared time. But the problem states that we must write an algorithm that runs an O of n time. So, how can we solve this? So how we may improve the time is that we can create an initial array, the length of nums, with each element being 1, and we will loop forward and backward. So when we loop forward, we will multiply the value by the prefix, and then we will multiply the value at nums to the prefix for the next iteration. And then when we loop backwards, we will multiply itself by the postfix. And when we loop backwards, we will multiply the value in the array by the postfix, and then we will multiply postfix by the value at nums for the next iteration. So let's go through this example. 1 times 1 is equal to 1, and then 1 times 1 is equal to 1 for the next iteration. Now we get here, 1 times 1 is equal to 1, and 2 times 1 is equal to 2 for the next iteration. Now we get to this example. 1 times 2 is equal to 2, and 2 times 3 is equal to 6 for the final iteration. 6 times 1 is equal to 6, and 6 times 4 is equal to 24 for the next iteration if there is, but there isn't. And now we're going backwards. 1 times 6 is equal to 6, and 1 times 4 is equal to 4 for the next iteration. Now we get here, 2 times 4 is equal to 8, and 3 times 4 is equal to 12 for the next iteration. Now here, 1 times 12 is equal to 12, and 12 times 2 equal to 24 for the next iteration. And over here, 1 times 24 is equal to 24, and 1 times 24 is still 24 for the next iteration. So the time complexity would be O of n, where n is the length of nums, because we will go through nums once and then go backwards twice, so it will always be n. And the space complexity would be O of 1, because we are returning this array, so this does not count as extra space. So now let's get to the coding part. So first, we can set up the initial array. We'll call it res1 times the length of nums. And now we'll set the prefix because we need to loop forward first. So now we'll make the for loop for I in range length of nums. And then we'll multiply the result at the index by the prefix. And then we'll set the prefix for the next iteration by multiplying prefix by nums of index. And then now we'll set the postfix to 1 because now we're going to loop backwards. So for I in range length of nums minus 1, that's the end of nums. And then we're going to loop to -1 and we'll increment by -1, which means increment backwards. And then we'll multiply the result of index by the postfix. And then we're going to set the postfix for the next iteration by multiplying postfix itself by nums at index. And then after finishing the iteration, we can return the result, so the resulting array. All right, let's see if it works. Let me check if anything's wrong. No? Okay. Okay, perfect. Well, thanks for watching. I hope this was helpful. If you have any other questions or concerns, please leave it down in the comment section below. And I hope to see you all again soon.